Compositions of functions are the next progression of operations with functions. And we've provided you with the definition here where it says suppose f and g are functions, fair enough, such that the range of g is a subset of the domain of f. Okay? So the output of g belongs with the input of f. And the way we write that is with this open circle. So multiplication is a filled dot, right? But that open circle is important. We read that f of g because we're actually going to use g as our x values, as our input. And so f of g of x, or we can also write it, this is f of x, where we're putting g of x in for x. Okay? Order is important. It tells us where we're going to start and where we're going to finish, right? So here we're looking at f of g. F of g, which means I'm taking g of x and I'm plugging that into f of x to get my ordered pairs. So we're going to start. When I look at g, right, I'm starting with 1, but in g that gives me 3. So I'm going to take 3, which is the output of g, and go to the input of f. And I'm going to come over here and I'm going to look, there's 3 as the input of f, and its output is a 3. So I write that down. There's my first ordered pair. Then our next ordered pair, 2. So I start with 2. The output in g is 2. I need to go find it in the input. I don't want this one because that's output, that's a range value. And we said in our definition that the range of g belongs with the domain of f. So I'm looking for an x value. It's paired with 4, so we're going to write down 4. Okay. And then 3. 3 is my input here. Its output is 4. I'm going to go find 4 in the domain. It's paired with 1. And then the last one, starting at 4, paired with 1. When I go find that back in the domain, it's paired with 2. And those are my ordered pairs. The reason this says if they exist, because if I had an output in g that didn't pair up to an input in f, I wouldn't be able to make an ordered pair. And so we wouldn't be able to use that one. Okay? Now we're going to go the other direction. G of f. So now we're starting at f of x, and then we're plugging that into g to get our ordered pairs. So if I start with f, I've got 1. 1 connects with 2 in f, so I go find 2 in g, and it's with another 2. I'm going to skip 3 so I can keep these in order, and I'm going to go to 2. 2 is paired with 4. When I go find 4 over here, it's with 1. 3 paired with 3 here. When I go find 3 on this side, it's with 4. And then my last one, 4, paired with a 1 here. When I go find the 1, it's connected to a 3. There are my compositions in both directions. Okay? It's a little abstract when we're just looking at the points. It may make more sense when we move on and do it with actual functions. Okay? So what we're going to do, again, order matters. So first, this one says g of h of x. So I'm going to take h of x, and I'm going to plug that in to wherever x used to be in g. So let's look at g. 3, there's an x. I'm going to leave parentheses, minus 4, so that we can take our h of x and plug it in there, x squared minus 1. Okay. Then we just distribute and simplify. 3x squared minus 3. Don't keep distributing. Okay, we've seen that a lot where once you start multiplying, it's hard to stop. The parentheses cut that off. I do not multiply by this -4 out here. I just bring it down. And then we have g of h equals 3x squared, -3 minus 4 minus 7. Okay, so now if we go the other direction, h of g, we're starting with h of x, right? And we're plugging in now g where x used to be. So that's where my x used to be, squared minus 1. I'm going to plug in 3x minus 4. And then when we start to simplify, we're going to have to kind of expand first before that gets any neater to look at. Squared means 3x minus 4 times 3x minus 4. Bring down the minus 1. 9x squared minus 12x minus 12x plus 16 minus 1. Simplify 9x squared, -12, -12, -24x, 16 minus 1 plus 15, and that is h of g. Okay. Lots of practice tomorrow. Don't panic yet. You'll be okay.